Hi everyone, and welcome to Mathsux. This video is going to help you pass statistics. In this video we're going to find the variance and the standard deviation of a given data set by using the formulas and by checking with a calculator. So what is variance? The variance represents the spread of data or distance each data point is from the mean. When we have multiple observations in our data, we want to know how far each unit of data is from the mean. So let's first look at the formula before we look at any questions. So we have this formula, and we always denote variance with a Greek letter, sigma squared. So that's what this is. So sigma squared. So this is really equal to the variance. So let's just label all of the different parts of our formula here. And this is equal to the summation, or the sum, of xi minus mu squared. So xi is just each observation. So whatever we're measuring. So each test score or each temperature, whatever numbers you are given. So each observation. And then mu is just the population mean or average. Yeah, so mu denotes the population mean. Another way you might see this is with x bar, which is the sample average. So don't get too caught up if you see different notation here. They're going to mean roughly the same thing. When you're given a set of data, you're going to find the average of that data. And n down here is just the total number of observations, or the total number of data points. So how many test scores do we have, or how many temperatures do we have? That's what goes down there. Now we're going to take a look at our question and actually find the variance of a set of data. So we need to find the variance and standard deviation of the following test scores. What we're going to do is first find the average. So we want to find the average of these numbers. So that's just, adding them all together and dividing by the number of numbers there are. So if we want to do 68 plus 85 plus 95 plus 70 plus 80 divided by 1, 2, 3, 4, 5. This is going to give us 78. So we know mu is equal to 78. So now we're going to kind of create a little table. What we're going to do is, remember, variance, it represents observations distance to the mean, xi minus mu. So what we're going to be doing is taking each number here and subtracting it by the average to see the difference. So we're going to do 60 minus 78, the average. 80, then the next number, 85 minus 78. 95 minus 78. 70 minus 78. And our last number, 80 minus 78. So this part represents xi minus mu. So when we get that, let's see, what do we get? So this is negative 18. This is 7, 17. And you can just plug these in our calculator, or some of them are just easy to recognize, whatever works. So now what we want to do is square them all. So that'll be like the next part of our table. And now we're going to do the next part of our table, which is we're going to be squaring these, xi minus mu squared. So when we square them, so minus 18 squared, so remember these are always going to be positive numbers, even if they're negative. So this is going to be 324, 49, 289, 64, and 4, right? These are all squared. So yeah, you could just plug these in a calculator, or again, ones you might know, 7 squared is 49, 2 squared is 4. And now, that last part of our formula is we're just going to add them all together, the sum. So the sum of all the squared deviations, the sum of all the squared deviations for each observation and the distance to the mean. So we're just going to sum them all right here. And when we do that, we get 730. So down here, we're going to have, this is the sum of xi minus mu squared down here. So if we look at our formula, we found the numerator, right? Let's write the formula over here. Xi minus mu squared all over n. So now we have the numerator. We just found that it's 730 over here. And then now we just need to divide by the total number of observations, which is 1, 2, 3, 4, 5. So we have 5 numbers. And when we divide these two, we get 146. Sigma squared equals 146. So now they want us to also find the standard deviation of our data. So standard deviation is a unit of measurement that is unique to each set of data. And it's used to measure the spread of data. And luckily, its formula is actually very similar to variance, because if you notice, the formulas are exactly the same, except now we have the square root. So here's variance, this is formula, and now standard deviation. So everything's the same, except now we are taking the square root. So we already found the variance. We know that sigma squared is equal to 146. So if we already have the variance, now to do the standard deviation, notated as sigma, all we need to do is take the square root of our variance. So when we do that, plug that into the calculator, and we get about 12. And that's our answer. Sigma is equal to 12. So another way we can do these problems is actually by checking our work on our calculator. So let's say you're taking a test and you have to show your work, so you do it manually, but then you want to check your work also on the calculator. So let's see how to do that. So if we go to Stat, Edit, Enter, and then let's clear this list and just plug in our numbers that we were given into this list. So our original numbers were 60, 85, 95, 70, and 80. And now go to Stat, go over to Calc, hit Enter, then hit Second and L1 because that was the list we just entered in, and then click Enter. So notice we get all these different statistics here. So we get X bar, which is 78. So X bar is the mean, which is what we got, 78, so that checks out. And then now, what else do we have here? We also, it says sigma X, which is sigma, which we found is equal to about 12, which we also got. And it doesn't directly give us the variance, sigma squared, right? But we do have the standard deviation, this 12.08304. So what we can do is actually square that number. So, include as many decimal points as you can. So 12.083045597. So if we square this, this will give us our variance. So let's plug this into our calculator. 12.083045597 squared. And then it ends up being about 146, which is what we got for sigma squared for the variance. So these all check out. And if you enjoyed this video, please give it a like and subscribe. Happy calculating! Need more practice? Check out Mathsux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!